This is the video lesson for two different lessons, 6-4 and 6-5, and we are combining them because, like addition and subtraction that are just the inverses of each other, these two lessons are multiplication and division, which are also inverses of each other. And so they're going to work very similarly, just in opposition. So here we go. Write multiplication equations. You can write equations to represent real-world problems involving multiplication. Select each card to see the steps, blah, 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 blah. Okay, I think in your book this is formatted as a table. Why is this? Let's make this bigger. There we go. Okay, so we've got words. Describe the mathematics of the problem. Use only the most important words in the problem. So that's just like figuring out what the word problem's asking you to do. Variable, define a variable to represent the unknown quantity, and then equation, translate the words into an algebraic equation. These are all the exact same steps as they were for addition and subtraction. You're just going to be using multiplication instead. So, to write an equation from a real-world problem, look for keywords, watch the animation to see how to write a multiplication equation. Okay, let's go ahead and watch this, see what they say.
Kosumi is saving an equal amount each week for 4 weeks to buy a video game for $55. You are asked to write an equation that could be used to determine the amount she is saving each week. To write an equation for the problem, start by describing the situation. Identify any key words and numbers. You know that Kosumi is saving an equal amount each week and that she is saving for 4 weeks in all. You also know that she will save a total of $55. Next, use the key information to model the problem with words. Kosumi is saving an equal amount each week. Combining equal amounts involves multiplication. So, the number of weeks times the amount she is saving each week is equal to the total amount she will save. Now, define a variable to represent the unknown amount. Let the variable a represent the amount saved each week. Finally, use the word model to write an equation. The number of weeks Kosumi is saving is 4. The amount she is saving each week is represented by the variable a, and the total amount she will save is $55. So, an equation that models the situation is 4a equals 55.
Cool, thanks, robot lady. Just note that in this case we are writing 4a to represent 4 times a. It's not wrong to use the little dot, but I really want to discourage you from using the x in this situation because once we get into algebra, like which we are, the x is a very common variable. So this is the best format to use. That being said, it's also something you want to think about in terms of what variable you use. Things like, for example, the variable L can look like a 1, so you want to be careful choosing your variable, and it's totally fine if you just want to use X all the time. They used A to represent the word amount, but you can use any letter. Just be careful that it doesn't look too much like a number. Okay, no. All right, example 1, write multiplication equations. Vincent and some friends shared the cost of a season ticket package for the local football team. The package cost $745 and each person contributed $186.25. Write a multiplication equation that can be used to find how many friends contributed to the ticket purchase. Okay, so we don't know how many friends, but we know the total and we know how much each person paid here. So, describe the mathematics of the problem. The number of friends or games times the number of seats or amount each person paid equals the total cost. Wow. Okay. We're going to define variable. We're going to use the variable f to represent the number of friends who contributed to the tickets. Wow. Okay. And then we can write our equation. We're going to do this by dragging. I believe that this is either filled in for you or you can write it. So we can go, this was the total cost. This is the number of friends, and this is how much they each paid. Is that right? No. All right. That's our total. This is how much each person paid, and this is representing each person. So the number of people paid this much, so those are going to be multiplied to give us our total. All right, now technically you could have put the F first and the 186 second in this format. That would have been fine. Talk about it. They also can write it like this, which I just mentioned a little bit ago. Does removing the multiplication symbol make it easier or more difficult to understand? That is kind of a preference, but I would say in this case, the decimal can be easily confused with that dot, so I like it like this better. All right, you do the check. We're moving on. Here's how to solve them. That was writing them. Here's how to solve them. And if you haven't guessed yet, it is pretty simple. So we're not going to use the multiplication tiles, the algebra tiles. If you're interested in that, it is available on Reveal Math. You can go look that up. I don't want to use that video. It's too long. So instead, we are going to look at these. So this is a chart in your paper, or in your books, I think. To solve a multiplication equation, use the inverse operation, which is division. When you solve a multiplication equation by dividing each side of the equation by the same non-zero number, you're using the division property of equality. Now, you can't do this with zeros, is what they're saying. So here's what this is. This is exactly like the addition and subtraction ones, except it's multiplication and division instead. So if we have 9 equals 9. That also means that 9 divided by 3 equals 9 divided by 3. If 4x equals 8, then 4x divided by 4 equals 8 divided by 4. So we're dividing by 4 on both sides because we want to isolate that x, which is being multiplied currently. So we have to do the opposite of multiplication, which is division, to get that x by itself. And if we do it on the left, we have to also do it on the right. Okay, no. Let's look at example 2. Solve 2x equals 10. We can use a model to do this, which I did skip the video of, but I'm going to still show you how to do it like this anyway. So if we have tiles, we could drag our x tiles to the left side of the mat to represent 2x, and then you can drag 10 1 tiles to represent 10, those little ones, okay? And then, oh, here we go. I was like, why are they not showing us this? All right, 2x, 1, 2, right? 2x equals 10, and then to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sorry that those are not in pretty little rows. Okay, so we've set it up, and then we can group the tiles on the right side into two equal groups because there are two x tiles on the left side. So we can have 1 over x over here, 1 over x over here, and if we put these into two groups, they're going to be two equal groups of 5 each, okay? I know your book probably is showing this a little different, but you get the idea. Then for every x that we have, 1x, there are 5 tiles of 1s, which means that x equals 5. So you do it like that. Or you could use this faster way and use the division property of equality. So first write the equation. Second, we need to isolate the x. So in this case, we have a 2 to get rid of. To get rid of our 2, because it's multiplication, we divide by 2. If we do that over here, we must also do that on the other side of the equal sign, which gives us 10 divided by 2. And then 10 divided by 2 is 5. Right? Just like adding and subtracting, just multiplying and dividing instead. You try it. And then we've got one more. And then we're going to do the other lesson, which will be pretty much the same. Example 3, solve multiplication equations. This time we've got some fractions to work with. 2/3 m equals 5/8. All right, here's our equation. Then we have to divide by 2/3 on each side because we want to get that m by itself. They're reminding you how to divide by multiplying by the reciprocal here. So 2/3 divided by 2/3 is the same as 2/3 times 3/2. And you can do that on the other side as well. And then you can simplify. And then, oh, whoops, I forgot to type it in. So when you multiply fractions, remember you can multiply straight across the top. So we can go 5 times 3 is 15, and then 8 times 2 is 16. So it doesn't let me type that. Oh, it doesn't, okay. Whatever. Okay. Anyway, do the check, and we're going to move on to the next part. Okay, so this is lesson 6-5, which it starts on page 369 if you need to turn the page there. This is literally the same as what we already talked about at the beginning, so I'm going to actually skip that. And this is actually also the same. So I'm not going to play this video a second time. It's a division problem instead of a multiplication problem. So you just have to be careful about what the words are saying so that you can figure that out. So let's keep going. Let's look at example 1, which is on page 370. We've got Benji rode his bike from Pittsburgh to Cleveland over the course of a 3-day weekend. His average distance was 48.5 miles each day. What was the total distance that he rode? So we can do this in a couple different ways. We can do, first we're going to do our words. Describe the mathematics of the problem. The total distance divided by 3, because it was a 3-day weekend. So that comes from the word problem. Then we've got let B represent distance he rode on day 1, average distance he rode, or the total distance he rode. What we want to know is how far he rode completely. So we want to pick that one. And then they're keeping track of it over here for you, by the way. And then we can set this up. So if we have an average of 48.5 miles per day, and the total distance, that's this, B, divided by 3 days equals that. So this is the total distance divided by 3 is going to equal our average per day. So it is a little more important here to make sure you're putting things in the right order. Try it, and then we'll look at the next one. All right, so that's how to write them. Again, we're going to learn how to solve them as well, but if you haven't guessed by now, you're basically going to do the opposite of what you did in multiplication. So I'm skipping the video. Again, if you want to see it, you can, or you can just read it. It kind of describes what the video shows on your page. You can look at that too. But we're going to move on. So to solve a division equation, use the inverse operation, which is multiplication. When you solve an equation by multiplying each side of the equation by the same number, you're using the multiplication property of equality. This is literally exactly how it has been for all of these. So if you want to isolate the variable in a division problem, you need to multiply to get that variable by itself. So what they're saying is algebra tiles are harder for this. Example 2, we're going to show you how to actually do it. Solve x over 9 equals 13. Remember that x over 9 is x divided by 9. So, loading scripts. All right, write the equation. X over 9, or x divided by 9, equals 13. to get rid of this 9, since it's division, we need to multiply. So x over 9 times 9, and then we must do it on the other side as well. 13 times 9. And then we can solve that by multiplying. So if you multiply this 9 on the denominator here by 9, it cancels out and you're left with just x. And then if you multiply 13 times 9, you're going to get 117. And no, I didn't just do that in my head. I looked at the book. All right. So the x is 117 in this equation. The equation x over 9 equals 13 can also be written as 1/9 x equals 13, just so you know. And then in that case, you still would multiply here to get rid of it. You can multiply by the reciprocal. Or you could divide, which is the same as multiplying by the reciprocal. So you try it in the check, and then we've got one final example here, which is just one more solving division equations with fractions, basically. So solve c over 3, or c divided by 3, equals 2/5. We write it out first, and then we need to figure out what to multiply by. So in this case, we have our 3 that is with the c, so we want to get rid of that. So in order to do that, we have to multiply by 3 on each side. It's not liking my answers. Does it want me to write it as a fraction? Oh my god. Okay, whatever. Anyway, I don't know why it's not accepting my answer. You multiply by 3 to get rid of the divided by 3. So these should be actually working, which it's totally not working, but these should say 3, and now it's not even letting me type at all. So anyway, when you multiply c over 3 by 3, you get just c by itself, and then when you multiply 2/5 times 3, or 2/5 times 3 over 1, you're going to get 6/5, which can be simplified down to 1 1/5. So either of those would be fine. And it's not even letting me type, so we're just going to pretend I see that it is written there in your book. So just rewrite the solution there. And then that brings us to the final check. So that is it. Hopefully these are just as straightforward as the adding and subtracting, and you can figure it out. If you're doing multiplying, you divide to get the variable by itself, and if you're doing dividing, you get the variable by itself by multiplying. That's it.